And just checking, now you can see the screen.
Yes.
Okay. Okay. Dear Roadex lovers, my friends and colleagues, welcome to the last Roadex webinar for 2022. Originally, this webinar was planned to be made by Hafdís Jónsdóttir, but unfortunately she couldn't do that. And as a backup, I promised to talk about a little bit about new gravel road survey techniques in what we've been working. And the history with this is that background work is that what we have been doing this year is a new e-learning package about Roadex. Roadex has been doing gravel and forest roads, gravel and forest road management, and the original ambitious plan was that this was supposed to be ready already in October, November. But once been writing the manuscript and collecting new data and all the new stuff, so we found out that there is so much new like interesting information that should be published, and this is so wide area that it took much more time than we expected, and now especially me, when I'm in a way retired from the CEO of Road Scanners, so I had more time and I've been doing this more, and we are supposed to get this done with the Laboratorio Uleabori, who is doing the technical work. I'm working with the manuscript and Ron and getting help with many people, but this should be ready by the end of this year, and we should be ready for publish that in January next year. And in this presentation, I will focus then on one chapter very much, and that's chapter 7, which is a survey and monitoring techniques, and especially over there the new. But a little bit about background, if we have an audience people who are not so much aware about role of gravel roads, forest roads in northern periphery areas and in Roadex partner countries. So basically roughly 1/3 of our public road network is gravel roads. And if we go to the forest roads in over there, so basically almost all the roads are forest roads here in are gravel road. On the other hand, we've been working doing some work also road scanners in Czechia, Slovakia, also on the forest road. And for instance, in Czechia, big part of the forest roads are paved roads. So not all the forest roads, we cannot say that not all the forest roads are gravel or unsurfaced roads or dirt roads. There are many names, but one special thing anyway with this is that we cannot ignore these roads, because especially now when we have a crisis here in Europe with the energy and maybe not food supply and raw material supply. So we have to be aware and know that about almost 100% of the product transportation on our societies are farming, fishing, forest industry, aggregate are using low traffic volume road network, and most of them or big part of them are at least one point they are gravel road. So their condition is very essential for the survival of the society. Then I'll have a quick review about problems on related on the maintenance of gravel roads. So this is like a doctor's book, a medical book with the different type of diseases, and I'll go them very quickly. So first of all, potholes, which are one of the most annoying problems. And the more we've been doing research, the more we know that these potholes are can be mainly related to the drainage problems, as you can see on the right hand photo which is from the Iceland. So when you see potholes, most cases you start to see also issues with the drainage. The other very annoying problem is also washboarding, and that is also like drive comfort, and washboarding is actually also a problem that could be a health issue. It's the wavelength washboarding is causing is also, according to the latest research, it is also increasing stress and causing stress also on the heart. Third problem, especially on the northern area, is differential frost heave. And on differential frost heave, we can define, and on this e-learning we are talking about positive frost bump, which means that the ice lenses, like in left, ice lenses are developing in the pavement structure, road structure, or under the subgrade under the road structure. Or we can have negative frost bumps, which means that the whole road is heaving up, but once you have a culvert which have a good foundation, like culvert should have, and that is not heaving, so then you can have negative frost bump, which, like in this case, can be like 30 to 40 centimeter lower than the rest of the roads. Third annoying problem is also dusting, and it's also traffic safety problem in sometimes, and also environmental problem, and that we can handle with the and there's a lot of theory about suction, osmotic suction, and matrix suction, and new thermodynamic theory about how we handle that. Then we have a rutting problem due to permanent deformation. Here's some photos of our older CTI test, Roadex CTI test in Sweden. And then you are not talking about elastic behavior, because it's only one heavy truck can cause these kind of problems in certain roads if the conditions are bad. Spring thaw problems. Spring thaw problems is where we have a frost and especially long frost winters, and then during the spring when the frost is thawing, there's that is can be very critical and make roads even unpassable. Then problems with all the road network, general problems where we have a different e-learning package made, and drainage related problems. And it's like in the left photo you can see a nice example. What if you have verges on the gravel road, and water cannot go away from the road? What happens then, especially on the hilly area? And the right hand photo is then on about the culverts that have not like installed, or foundation is not properly done, and frost is pushing it up, this culvert, and of course this kind of culverts are not functioning at all. And finally is road widening. And road widening is generally also maintenance problem. In many countries, this photo is taken from one Eastern European country where there were no like experience or general practice about keeping the road cross section this for instance, this road was originally about 7.5 meter wide. Now it's probably 20-meter wide when it's never been kept as an original shape. And of course, the structures are only on the center, and the rest is just some wearing course of mud. But in general, what we are all these problems, what we have been seeing and have been showing so far, they are in when you are talking about road condition management. So they are evaluated by visually and ranked visually. And there's no possibility any kind of continuous or objective or repeatable monitoring. It's always visual evaluation. This is good or not based on the fixtures. And if you are not doing visually and objective weights, so it's a very difficult to have a criteria, good criteria, what is the condition of the road. And this presentation now very much focuses on technologies, how we can measure these problems that I already showed. But before that, a little bit about older systems that we've been already mentioning in earlier. So we have a DCP, dynamic compenetrometer, which is extremely good because you get stiffness and also structures, falling weight, lightweight deflectometer, LWD, GPR as a cross section, and it's very visually shows also how the pavement structure in gravel road is all the layers are focused on the wheel pads, and this deformation is so big issue. And then GPR on the continuous, and of course there is also sampling techniques. And we've been earlier also discussing on Roadex e-learning and reports, how do you do design. Gravel roads are very good roads to be designed by Business-Codemark theory, where you are calculating the moduli values of the structures, and then you can make a rehabilitation plan. And for instance, here you can see we have a target bearing capacity value of 85, and then a red one is initial values, and then green one is the design values for the bearing capacity after the construction. Which means that you are combining the thicknesses and from the falling weight data, calculating the moduli values, and then you start to do the design, how much new wearing or material you need to go up to the target value. Another issue that we've been working already more than 20 years is gravel road wearing course quality, and GPR dialectic value based surveys. And what we've been doing, finding out that once you use GPR surface reflection technique, so we know that the optimum dialectic value of good quality wearing course is somewhere between 12 and 16. Which means that it's not dusting, it's enough wet that it's not dusting, but it's not so, it's less than 16, which means that it's not like susceptible for the permanent deformation. And if you are looking wearing course surface on this kind of area, so it's a very beautiful and could be drive comfort is very close to the pavement. Third one, very long time already used, is just the digital videos on, for instance, on drainage management, where you have before videos, left ditch and right ditch, and center when you have you can document that how the condition after the drainage was improved. So that's like what has been done already before. But now I'm focusing on the new techniques that has been just recently tested. And now we are talking about not so much anymore on GPR, only a few issues, but especially what you can do with the laser scanner or LiDAR when you have also IMU and GPS, and also accelerometer data, where you can measure the roughness, and how you can do them on the diagnostics and maintenance management on the gravel roads. First of all, and I would say one of the greatest benefit with the LiDAR is that all engineers, we've been very much used to use cross sections of the road, and with LiDAR you can get the cross section of the road, and depending on the speed, so even every 10 centimeter or even more dense, and once you get this cross section of the road, we have a software that you can measure or track automatically the critical points on this, so road center, road shoulders, ditch bottoms, and now in the future you can also outside slope, and start to track outside slope corners. And once you can do them, so you can calculate continuously road width. What I already said, that it's very critical that you are not allowing the road get too much wide, because if it's getting wider, it's also getting thinner, and then you are starting to have problems. Then you can measure cross slope angle, which is also critical to have this 2 to 5% cross slope in the straight road if you have crown shape, in the slope angle, and of course outer slope angles. And what you can do with the laser scanner or LiDAR data is once you are putting this LiDAR data to, so basically what you can see here is these road shoulders that I already showed, and then there are the ditch bottom, and you can show them on laser scanner remission map. And for instance, in gravel roads, basically also from the remission map, if you have water or if the soil is very wet, so you can see also on a darker color many times on that. And in the future, for instance, in Finland, the goal is that you are seeing also the road area from the land survey data. So you can also see how much, for instance, you can get wider of the outer slope in, and not to go and still staying in the road area. But the next slide here is road width. And for instance, in this road, the design width was 5.5 meters. And for instance, here in this case, you are seeing that the actual road width is more than 6.5 meter. You can see exactly on this page also that you have water in the ditches. And what you can see also that the cross slope is not within the area. So cross slope is about 2% or less. So the road is much too flat. So this road widening and flat road are always working together. And once you get the road start to have a deformation issues, mode 2 rutting, you are getting wider road and you getting flatter road, and you should react on especially on these cases. And here's just an example of these sections, and seeing the place where you have, and you can see also spring thaw weakening problems over there. So it's once you have a dry road over there, so this is very wet. Another example of this, when you are combining then with that on GPR, you can also with the LiDAR make like a surface contour map, which is like a contour showing colors, what we call rainbow map, showing what is the shape of the road if you have a deformation. But the biggest and interesting issue here is that this black curve is the bottom of the road structure. For instance, here it's about 40 centimeters. Here it's about 30 centimeters, less than 20 centimeters, the total thickness. But these are red and right one are ditch depths. And for instance, in these areas, you are seeing ditch depth almost to on the surface level. And we know from the general basic principle that its depth we should be always 20 to 30 centimeter deeper than the bottom of the pavement structure. So they are much too high on these sections. And once they are high on these sections, also you are starting to see basically deformation problems. But for instance, in road surface dielectric value, what I just told you, that if you have dielectric value higher than 16, then your surface is exposed to permanent deformation and surface to weakening problems, and in many cases it is like that. So basically this is the section, and what you can see also on over there, that exactly on where you have a high values, you see also that ditches are much too high up, which means that what we should do on this case is go and excavate ditches at least 20, 30, 40 centimeters deeper to get this is a very potential place with the spring thaw weakening, and actually already there are some still, even though this is a summer, there are some signs for that. Then if you want to going for the differential frost heave, so if you want to measure frost heave bumps, which is a general evaluation that, okay, how much you have a frost heave bumps. So what you can do is that you turn this LiDAR on 90 degrees angle, and you start to measure cross a longitudinal section. And then on one scan, you can measure 50 meters in front and with 50 meters behind, and then you can make a evaluation. And again, as I showed you, you can measure positive bumps like in this and measure it's 12 centimeter, or you can measure negative bumps when on the culvert, and this case it is about 20 centimeter. Very quickly and nice way to do the analysis. Then potholes. Potholes also on laser scanner data, or both on forest road or gravel roads. Potholes you can analyze and basically, for instance, in road scanners we are now working with the automated detection algorithms from the LiDAR data to detect potholes, how deep they are, where they are. Of course, these potholes doesn't look round as it is on the figure, but this is because of the scaling. We have about here about 100 meter, and here it's only about 3 or 4 meter wide. So these potholes look slightly weird, but this can be calculated and detected. Then rutting also, talking about deformations, and of course rutting is a challenge because you have a wearing course and it mays. But this is one older test in Sweden, and I think this is a great example to see where you have a bearing capacity issues. And this is a case where we measured this gravel road in May, in July, and in August. And in May it was before the spring maintenance. So this is the deformation on after the spring, and you can see then in July after the grading and early summer grading, it was pretty fine, but in August you started to see already deformations on certain areas, and this is indicating that if you have to improve bearing capacity in certain sections, you shouldn't probably put all the very valuable bearing capacity or base course aggregates everywhere, but you should focus especially on these sections where you are seeing. So it enables this kind of monitoring, which can be automatically collected. You can focus only on this section where you are seeing these deformations. Again, LiDAR data verges, what I showed already on this very bad looking erosion on the gravel road earlier in the falls, and the main reason with this kind of erosion is always verges. And verges should be always removed from the gravel road. Make sure that water is going away from the road surface. and with the there are algorithms, and with the cross-section evaluation you can detect where you have verges, and make a design where also if you have a grader, or even with the underblade, or whatever tool you can use to remove these verges. Dusting is also one possible way to monitor gravel road. And here the idea is that when you have a LiDAR behind as you see in the photos, if the LiDAR is behind the vehicle, and if it's dusting, so the laser scanner laser points that it is sending, they are hitting and reflecting from the dust particles. And if your road as a wearing course has a dusting problem, you are starting to get these reflections above from the actual road surface. And when you are presenting them and basically calculating how many points you are getting on this section, so you can monitor very easily how much you have a dusting problem at a certain time of the year, or when it is. And here's just one example about 2 kilometer long section. And for instance, in this 2 kilometer long section in northern Finland, you have pretty much only 4 less than 200 meter sections where you have a dusting problem. All the rest is okay. And now when we are talking about dust suppression and dust binders, they are chlorides which are not very environmental friendly. So basically you could do the dusting also, like preventative dusting with this data, and you are putting dust binder only on the known places where you know the dusting, but saving the nature and groundwater, that not putting chlorides on the other places. Here's also another nice example of the same technology what we used a few years ago in Sweden in test. So May, when it was a really dry May season, very bad dusting, and then in August, and basically you can still see lights of dusting exactly on the same spot, but definitely you can see the worst spot and react them, and don't have to use dust binders all over the road. Save money and environment. Then we go a little bit about further from this more specialized issues to more like affordable, cheaper systems and real-time system, what we are calling Road Doctor Maintenance Controller, that we've been using also now testing and developing. And this system is a system that you can install them quickly to any vehicle, and we've been using them in road scanners vehicle and some maintenance contractors vehicles and also the engineers vehicles that are monitoring the maintenance, gravel road maintenance. And this system has an accelerometer under the driver's seat, which is found to be the best place to measure drive comfort that we are like experiencing. We have a LiDAR, not necessary all the time, but the same LiDAR, for instance, dusting, and this can be used. We have a camera, and we have a GPS on the roof, GPS antenna, and 4G, 5G antenna over there, and data collection unit. And this system collects the data real time, and you can see the results in 2-second delay in the web if you have a 4G, and it doesn't require any experience on data collection. You just drive and all the results are there. What we are measuring on accelerometer, there is a lot of different parameters, but basically what we are mainly talking about vertical acceleration, which is roughness, then pitches, which are mainly like bumps, and then roll, which is a changes in the crossfall. And here is a comparison also with the IRI values, which is here, and there's and these measurements have been doing in May, in July, and in August, and what you can see the changes on, and also because these forces are depending on the data collection sheet, so you can make a correction also. But for instance, here in acceleration, you can see that pretty even, but in August there was a very high acceleration, and you start to see also some August, also some deviation on the pitch values and also on the roll values. But in general, this is indicating that you have most likely like washboarding and pothole issues. What we have been using this system now almost 2 years in central Finland area, in two maintenance area, Karstulan, Äänekoski maintenance area. And results are very, very interesting. Quite much information that we never knew and could not predict like earlier. And for instance, one interesting result is that when our roads are smoothest, what we found out, that even this is a gravel road, but paved road also, our roads are best in November and early December. Then you don't have any, you have pretty much less than 3% of the roughness, any kind of roughness issue in the whole gravel road network. And then it starts to increase from December, January, and that, of course, that is a frost. Frost enters to the pavement structure and subgrade and starts to go develop differential frost heave. And the highest unevenness you can measure always in April in central Finland. Maybe in May in northern Finland, and then when frost starts to thaw, you are going down. But for instance, in May and August, after the spring thaw weakening, after the spring thaw maintenance operations, it's getting better. But then again, mainly the same problem that appeared here are starting to pop up also on July, August. And then again on September, when it starts to be the autumn maintenance period, it's going down, and you can see the maintenance operation. But the trend is very clear on and you can see where you have the problem. And if you put them to a map, so you can then start to see that this is from Äänekoski gravel roads in last summer. And from that you can see yellow roads are pretty much excellent roads, very nice road. But then what you can see also, like and this is like evaluated as a 500-meter average, so you can easily detect visually on these maps that these gravel roads are those who needs to have a more like a clear analysis what is wrong. And once you can take one gravel road section and start to do further analysis, and like in this road, so now you can monitor automatically these results of that, and started to calculate that, okay, what type of problems are. And what we could find here is 4 type of problem. First of all, this number 1 is that it could be really bad frost related problem, because it was throughout the year until October. In November, when it was made even and frozen, then it disappeared again. And then number 2 and 3 are very much related to the wearing course maintenance problems. And in this case, they were mainly washboarding problems. Number 3 problem was managed to fix, and it's most likely the reason that grading was made in late June deep enough that they didn't come back. But for instance, if you are not doing grading enough well and with the heavy, so they come again very soon, as you can see in the cases number 2. And then the third one here is number 4 case is that you are starting to get certain problems on late summer, and that could be related to some drainage issues or another problems. Then about how do you detect different problems? So far we've been talking about general roughness issue, but if we are talking about these 3 main problems on gravel roads, what we should do, and they are these frost bumps, potholes and washboarding. They need to be detected slightly different way. And how you can do this new technologies to detect where it is a frost bump. And frost bump is what we are using and developing is what we call pitch analysis, and we are doing some parameters calculating pitch values and comparing them in the pitch values in late summer. And if you have a high pitch value in the winter time or spring, and you don't have anything on over there, it's definitely a frost bump. And I can tell on our experience, we have a pretty extensive data that if your pitch values are start to be like 1.5, more than 1.5, is that these black ones, so they are really bad ones, and this kind of problems you don't see in the summer, and they are, so to say, what we can call dangerous frost bumps. Then about washboarding. Washboarding is a very short wavelength unevenness problem. And that can be analyzed if you are doing wavelength analysis or wavelet analysis. So you are just analyzing the amplitude of short wavelength. And if you have washboarding only, which means that it's a surface related problem, according our experience, so you have very high amplitudes on less than 1 meter wavelengths, and then if you are taking another like 0.5 to 2 meters wavelength, but you are not you don't have any big issues with the longer wavelength, and that's an indication of washboarding. But once you are going to, for instance, potholes, the general trend is that you have always longer wavelength, even though you don't really see that and notice, but at least what we see, that then you have a long wavelength, and that means that it's also deeper in the structure. And that is why I already told you that once you have a potholes, you may, I would say, in 80 to 90% of the cases, you have also drainage issue, and like in this case, you don't, the ditch is totally filled, and what like road structures are wet, and then you are starting to have so that's like a clear indication that you are starting to have potholes. So in general, as a summary, I've been using already my time, so just quickly that if you are going to the gravel road condition monitoring, so first of all, it has to be automated, how we see automated, and the price cannot be too high and doesn't need so much like experienced personnel, because the maintenance crew and monitoring, they have so many other tasks to do. But it's a first step on if you are talking about asset management system also on the gravel road. And as I said, automated data processing, cloud storage. And also what is good with that you can monitor gravel road like laser a beam-based system, you cannot measure that. It is the accelerometer is for if you are measuring roughness, and also in winter you can measure like you have already seen over there. Then seasonal changes, monitoring, time series analysis, as we've been showing. Then also one issue, what we have been finding out, that if you are talking about public, if you saw this map and talking about IRI, nobody knows what is IRI. But in school, almost everybody who have been into physics, they know G. And if you are talking about G forces and everything else, so it is much easy to adopt and accept also for the public audience. Also, if we are going to open data system, so this is real-time condition of roads, and people can see, for instance, ambulances, everything else that they can see also on the gravel road, what is the condition. Then on the maintenance crews also, if it's on the web and if it's on the cloud, then you can go to the site and see the same data in the tablets or fields. And I think above the all is that it's objective monitoring and maintenance contract. So you can with this system you can go to more specification of maintenance contract performance, and it's not any more question about visual evaluation. And you can also compare two areas like we have been doing in central Finland, that okay, this contractor has been successful on attacking these problems, but have a problem on the other problems, etc. So it is we are moving from this visual work very much towards a very objective monitoring system, which is in a long term will definitely increase the value of the works. And I think okay, this was the last slide. So yeah, and here's just one last technology. This is a short iPhone like application that I have been using with the iPhone. You just walk on a gravel road if you find a problem places, and with your cellular phone you can make a 3D model of a deformation, like in this case you see the widening and everything else. So this is definitely the future. These systems are, if you can make this kind of system already with the roughly 1,000 euro cell phone, so these systems are definitely the future, and prices are going down, so they will be in the future also very affordable. So that was my message today. And is there any questions? Just